Okay, here we have the last of the sine law questions. This one says find the value of the missing obtuse angle marked x. And again, like the last question, obtuse angle means greater than 90 degrees, obviously. But what it means in sine law is that we've got to take 180 minus our calculator answer to get the proper answer for this question. So we've got to remember that at the very end. Then they want us to round our answer to the nearest integer, which means no decimal places in this answer. Now in complex shapes like this, easiest thing is to identify I've got 1, 2, 3 separate triangles. The answer I'm looking for is in triangle 3. I'm not going to have enough information out here to solve it right away. So usually what I've got to do is start at the other end of the complex shape and work my way around, and that's exactly what I have to do here. So I'm going to redraw. I'm going to work in shape 1 over here. I'm going to redraw it. Let's make my life a little easier. So there I've got an angle of 20 degrees. Here I've got 120 degrees and a side length of 28. And what I want to do is find this side length here and then this side length here, so I can transfer the numbers from one triangle. So I'm going to transfer this side length from triangle 1 into triangle 2 because that's a shared side. Then I'll find this side, transfer that from triangle 2 into triangle 3 because that's another shared side in this question. So I'm going to start with triangle 1. I'm going to label it A, B, and C, and then the side lengths across get lowercase a, lowercase b, and lowercase c. So when I write out the sine law, I've got A over sin A equals B over sin B equals C over sin C. For the side that I want is lowercase a. I'm going to replace that with x. So x over the sine of 20 equals b over sin b. I don't know either of those values, so I'll leave that just the way it is. And that's equal to lowercase c, which is 28, over the sine of angle c, which is 120. Now I'm not going to use these values in the b fraction at all. So I'll rewrite x over sin 20 equals 28 over sin 120. And to solve for the unknown here, x, I'm going to cross multiply, so sin 20 times 28 divided by sin 120. So I've got sin 20 times 28 divided by sin 120. That gives me 11.058. 11.058, which is this side length here, and in the drawing that's this up here. So I'm going to fill in this value, 11.058. And now I can move on and work into triangle 2 here. So if I redraw triangle 2, so here I'm done with triangle 1. If I redraw triangle 2, it looks like this, with a 40-degree angle here, a side length of 11.058, and what I was looking for is this side over here. Now I've got to catch that this is a right angle triangle. Being a right angle triangle, I can use SOHCAHTOA, and that means I figure out which angle I'm working with. It's the 40. So I'm going to label it. Hypotenuse is always across from the 90. The opposite side is always across from the angle, and the third side is adjacent. Now I have adjacent and I want hypotenuse. That means I'm working with the A and the H, so I'm in the cosine. So I'm going to make those into equivalent fractions and then multiply 1 times that divided by cos 40 to find the unknown value. So I'll do 1 times 11.058 divided by cos 40, and that gives 14.435. So x is equal to 14.435, and that is this measurement right here, 14.435. And now I'm done with triangle 2. That was the shared side between triangles 2 and 3. So now I can get to work in triangle 3. So I'll redraw triangle 3. This is the angle I'm looking for. This side right here, 14.435. Here is a 30-degree angle, and this side was given as 20 degrees. So on this one, I'm back to sine law because I don't have a right triangle. So I'll label A, B, C. Lowercase a here, lowercase b here, and lowercase c on this side. Now the sine law written out looks like this. So I'm going to fill in what I know. Lowercase a is unknown, so is angle A, so that one stays just the way it is. Lowercase b is 20. Sin b is what I'm looking for, so I'm going to change, instead of capital B, I'll put the x there. Equals little c 14.435 over sin 30, which is angle C here. So I'm not going to use the a's, and when I solve for this, sin x equals, cross multiply for the answer to that. So 20 times sin 30 divided by 14.435. 20 times sin 30 divided by 14.435 equals 0.6927, 0.692760651. To get rid of the sin in front of that, because remember that's sin x, to get rid of the sin in front of that I have to do the sin minus 1 on the calculator and press equals. I get 43.849. X is 43.849. But because I'm looking for an obtuse angle, I have to do 180. So remember, I'm looking for obtuse. So here I'm going to have to do 180 minus 43.849. 180 minus 43.849 leaves me with 136.151, which to the nearest integer they were looking for, up here they said nearest integer, becomes 136 degrees. And that is my final answer.